So when it's cold outside, we long for the hot or warm temperatures. And when it's warm outside or hot outside, we long for the cold temperatures or the cooler temperatures. Why is that? Maybe it's a Canadian thing. I don't know. I've lived in Canada all my life, and every single year, we, myself included, go through this process of, man, it's hot in the summer. Can't wait till it cools down. And then when it gets to the winter, oh, I'm so sick of the cold and the snow. I can't wait till it heats up again. And of course, in between, we have like maybe, I don't know, a week of spring and a week of autumn. So the temperate parts, the pleasant parts, they last they're very short, and it seems the extreme heat and the extreme cold is what we're left with. I don't know. Well, I might as well suck it up and enjoy it. You know, one of the fun things about the hot weather, the summer, is getting to go to water parks, right? Water parks are great fun. One of the things I like about water parks is those oversized playgrounds, right? Where all of the playground equipment is actually pipes and water is flowing through them. And you can go to different parts of that playground and kind of, there's holes in the pipes and there's water coming out, and you can cover one hole and then the water starts, getting faster through the other holes and you cover more holes. And of course there's more holes and you have hands. So it's always fun to try to cover all the holes. Oh, the piece de resistance for all these water park playgrounds is the bucket. The giant, enormous bucket that usually sits right up top of the playground. And it's got this funnel of water or hose of water filling it up. And it fills it up slowly, of course, right? But this bucket is giant. And then when it gets close to the top, you know what happens, right? The bucket starts to tilt and it starts to tip. And you look up and all the children start to scream as the anticipation builds. And then the bucket spills and all the water just whoosh, it just falls over you. All the children love it. The little babies get swept away. It's so much fun when that bucket falls. I love it. One of the other things about water parks is the water slides. They're a lot of fun, right? There was one water park in particular I remember. This was way long ago. I was probably a teenager at the time, and I was there with two of my friends. So there's three of us. And there was this water slide that we looked at and we're like, wow, we've got to go on that water slide. It was this kind of water slide. I remembered it was all blue. So all of the slides were blue. And it was one of those water slides where you have to take the floaty. So you got to go on the little air ring or the floaty ring. So you just don't go down on your bare, without any protection, I guess. Anyways, this water slide, it was epic to look at because you look up at it and it looks like this giant ball of spaghetti. Like the water slide paths were going all over the place. Like it looked like there was some going straight down. It looked like some were going even up. I don't understand that. It even looked like there was areas where you can kind of, like a saucer or something, and you would kind of go in and you kind of just go round and round and round and get lost in these areas. But it was just this impossible spaghetti of slide. It was gorgeous. So of course we got to go up, and as epic as it looks, you're going to get a big lineup. As expected. So, we go to the bottom, we pick up our little the air tubes or whatever, you hoist them over your shoulder, and you start getting into the line. It took 25, maybe 30 minutes to get to the top of this thing. A, because of the lineup. B, because it's so high. It's a tall ride, so you got to walk up all the stairs. Anyways, you get to the top, and then I understood why it looked so impossible. It's because it wasn't just one slide. When we got to the top, there was 3 entrances to this slide. So it's actually 3 water slides all built into one. And that's why it looked so incredibly complex. Okay, now it made sense. So anyways, we get to the top. And I love that moment where you're standing right behind the person in front of you and you watch them and they sit down into their air tube and then they go. And then they go and the head just kind of disappears and it's gone. I'm like, ooh, that's fun. And then your turn, right? So you get up into you stand at the top of the slide. And of course, the water is spraying from both sides to get the water running on the slide. And it's spraying directly on your feet. And that's another moment that builds your anticipation. And then, you put your floaty down and you sit down in the floaty. Then the helpers have to hold you. If they don't hold you, you're going to go. You got to make sure there's enough distance from the next rider. And then finally, they give you the push and off you go. And I remember this, you go down and I think you duck down a little bit. Then I remember I veered to the right and then I veered to the left. And it looked like the slide in front of me vanished. It was a sheer drop. Oh my gosh. So I get right to the edge and I felt like I was airborne. And I was falling. I know it wasn't straight, but it felt like it was straight. it was so fast and so scary. I was glad my shorts were already wet. So, man, it was so fast. We get to the bottom, this epic splash, and then you have that long length of slide where you start to slow down. And then that was it. That was it. I mean, I got up and I looked back. I'm like, wow, that's pretty high fall. But my ride was all of, I don't know, 6 seconds. It was so disappointing. I'm the kind of person, I would much rather prefer one of those rides where you get into this nice, lazy, long, kind of swirly ride where it takes you into some saucer, you get lost, or you go into some lazy river. Like, I want to ride, if I'm on a water slide, I want it to last. Okay, I want it to last. I don't want it to be over fast. I'm not one of those, I don't enjoy the steep, quick thrills. So anyways, what made it worse is my other 2 friends that were with me, they got the longer ones. So it felt like it took minutes for them to appear at the bottom of the slide. And of course, I was standing there for so long because mine was so short, just a few seconds. Anyways, I mean, I was so disappointed. I didn't want to go back in the line for 30 minutes to go for another 6-second ride. So I said, you know what? I'm just going to go back to the bucket. I enjoy the playground bucket. I'm going to like that one a little bit more. So I did that. But you know what? This water slide kind of gives me an idea. If you watch the previous few videos, well, the last video I went on a bit of a rant. I went on a bit of a rant about how I really dislike this methodology used to dim LEDs. But if you watch the video just before that, we ended up finishing off with this circuit that helps us drive an LED. And what we were talking about at the time was a way to dim the LEDs, so to make it so that we can control the intensity of that LED. And of course, that's when I went on this rant about pulse width modulation and that this other methodology that's used to dim LEDs and how I believe it's terrible. But this water slide idea this water slide discussion has given me an idea about how we can actually control the intensity of our circuit, of our LED, without using PWM or pulse width modulation. See, remember when we got to the top of the slide, there were 3 choices. Well, the way our circuit was built so far, it only had one choice to go down. And the resistor, or what we call the parachute resistor that helps control the current, you can't exactly change that throughout the day, right? That's a resistor. But if we give our circuit multiple choices to go down, well, one of those choices could be steep, like the one that I went down, right? And maybe that's going to result in a very bright light because it has a low resistance and you're going really fast. Another one of those paths maybe could be a little bit longer. You get lost on one of these saucers and it takes a little longer to get down, so you go slower and it results in a little bit of a dimmer LED. And then we can have another path, which is yet even slower. Maybe it goes down to some lazy river. It takes you around the entire park before you get back. And of course, that one would go really slow, so you'd have an even dimmer LED. But we'd have multiple choices for the circuit to use. And then if we added a gate, let's say, so we put gates in front of all of them, and then we controlled the gate. So we can open a gate to allow current to go this way, close that one if we don't want that intensity, open another gate to allow current to go this way. So if we had these 3 paths and 3 gates, we would be able to control the intensity of our LED, wouldn't we? All right, let's bring back the circuit so you can see what this looks like. I'm going to bring it up on the screen here. There we go. All right, so this is the original circuit that we had. Where's my pencil? Okay, here it is. So this was the original circuit that we had. And, if you want to get a refresher, go back and take a look at some of the older videos. You'll see what we're talking about. But really, this only just has one path. Right straight down here, one path through this parachute resistor that was sized appropriately. And if we did it last time, I think we had sized this, there it is. We sized it for 105 milliamps. So that way, that's the kind of current going through the resistor or through the LED, and that resulted in a certain brightness. So if we add multiple paths here, so we're going to add a couple other paths, and then put a different resistor so we get a different current on each path, that would result in a different intensity for the LED. And then all we have to do is gate it. All right, so I took the liberty of drawing this ahead of time. Let me get this up on the screen here. So this is my papers are getting a little bit messed up here. All right, and let's bring it down so everyone can see it. There you go. All right, so this is pretty much the exact same circuit we had before with a couple of differences, right? One, I've expanded the options for the current to go down. So when it reaches this point, after we get past that little feedback, contraption over here, then we have 3 possible choices. Just like the top of the water slide, we can choose 3 different slides to go down. And each slide will have its own resistor, and we'll size these differently. And each slide will have its own gate. In this instance, I've just used a switch. So if we depress, let's say, switch 1, then that means this path will be enabled. If we push switch 2, then this path will be enabled. And if we push switch 3, this path will be enabled. And if these 3 resistors are different sizes, that's going to result in a different current going through our LED. So in effect, we can control the intensity of this LED by choosing one of these switches. All right, we're on to something here. So let's put some numbers on here, and we'll be able to figure out exactly how much this intensity will change. So I did a little bit of numbers. Actually, before I show you the numbers, let me show you how I came up with these numbers. So the resistor, sorry, you can't hear me. Here we go. The resistor that we originally used was this one. This is a 6.2 ohm resistor. So that's the one we had for the previous circuit, right? So that's the one we have right there. And then I just happen to have a couple other resistors. So I have this one, which is a 12 ohm resistor. And I also have this one. This is a 24 ohm resistor. So 6.2, 12, and 24. So 6.2 is almost half of 12, not quite, but almost. And 12 is exactly half of 24. So one of the things that I did, I actually made a couple of assumptions here. In order to make the math a bit easier, because remember, I said we don't want to make our math too complex, I changed this 6.2 just for the purposes of our calculations to 6. Okay, so assume this is 6. This is one of the assumptions we're going to make. 6 ohm resistor. So that means that this is exactly half of this, or R1 is exactly half of R2, and R2 is exactly half of R3. So this is really nice. We're going to result with something a little bit easier to grasp if we change this. The other thing that I made the assumption on is on the voltage across these resistors. So if you remember, let me take this and go back to the previous, here we go. Let's go back to the previous schematic. Okay, so if you look at the previous schematic, the voltage across the resistor, remember, we actually built this and we measured it. It was 0.68. We know that the voltage here across this this arm of the diode, or this arm of the transistor, is between 0.6 and 0.7. It's usually between 0.6 and 0.7. So one of the other assumptions I'm going to make is, just to make the math easier, let me bring this old sheet back here, is I'm going to assume that that voltage is not 0.68 as we measured it. I'm going to assume that this voltage over here is 0.6 volts. That's going to make things a little bit easier for us. Okay, so let's make a couple of assumptions. So my assumptions, just to recap: 1, I'm using a 6 ohm resistor, not a 6.2, and I'm using 0.6 volts as our voltage across this area. Now the neat thing about this is, if you remember, the voltage across a parallel circuit's all the same. So the voltage across all of these resistors will be the same. They're all going to be 0.6 volts, which is going to make this really nice and neat. Okay, so those are pretty fair assumptions to make. Let me show you the calculations that I did. I'll bring it down here. All right. So using, basically the Ohm's law, which is right here, we can calculate the current that's going through the path, basically by looking at the voltage and dividing it by the resistance. So the first situation here, the first scenario, I have switch 1, which is a 6 ohm resistor. Remember our assumption. And so if you do the math, we end up with 100 milliamps through it. And this is pretty close to the actual number which we got, which was 105, using a 6.2 ohm resistor. Okay, but if I use a 12 ohm resistor, so I'm doubling my resistance, and look at the resulting current. It's half. Double the resistance, half the current. I'm now at 50 milliamps. If I double it again to 24 ohms, I'm halving my current again to 25 milliamps. So this is really cool. That means that these 3 current paths over here and these 3 resistors will give us a very nice 3-level intensity change. But 3 is not that much, right? I mean, three intensities, you'll actually be able to see a very sharp jump between those values. So we'll probably practically need more than 3. But if I want more than 3, that just means, well, I guess it's simple, right? All I got to do is just keep adding. And in a way, I can probably just keep doubling my resistance values and keep adding multiple paths. But this could get a little big, right? I mean, 3 right now, if I wanted, let's say 8, then I'd have to have 8 switches and 8 resistors. And even 8's not good. I mean, if I wanted to have a nice smooth intensity change, I'll probably want to have, I don't know, at least a dozen, maybe 2 dozen, maybe 24, maybe 30. That's a lot of current paths. That might get a little complicated. But here's the interesting thing. One of the things about current is, unlike the water slides, you know, when you get to the top, you have to choose one of the slides to go down. You can't split yourself in 2 and go down both, although I would love to do that. Well, current behaves differently, right? The energy that comes through this circuit, it doesn't choose a path. It will take all available paths. So that means that if I turn on switch 1, it's only going to go through R1. Like I said before, if I turn on R2 or switch 2, it's going to go through R2. But if I turn on both, well, that means it's going to go through both of them. And in that scenario, the current basically gets added together. So, as an example, if switch 1 was closed, which is 100 milliamps, and switch 2 were closed, which is 50 milliamps, then the resulting current I'm going to get through this LED is actually this plus this. I'll get 150 milliamps through that. So that means for these 3 switches, I can have a bunch of combinations that's going to give us a different current through that LED. Now this is interesting. Let me do the mathematics. I'm going to actually build a table here so you can see all the different combinations of switches, and we'll take a look at the different currents that result. Let me do the math. Let me do the table here. Look at that. So I can see that I actually have 7 different combinations. 8 if you'll include 0, right? So I have 8 combinations that I can get with 3 switches. And interestingly enough, the way this works is with only switch 3 down, I'm getting 25 milliamps. With only switch 2 down, I'm getting 50 milliamps. But if I put both of them, I get 75. And then I keep going through these combinations. Every single line here is an increment of 25 milliamps. Well, isn't that convenient? The way these resistors are sized, I'm going to get a nice consistent change in my intensity. So 3 switches gives me 8 possible combinations. If I simply add 1 more switch, I'm actually going to double the number of combinations. So 4 switches will give me 16 combinations. 5 switches will give me 32 combinations. 6 switches, and I'll have 64 combinations to work with. Well, 64 different intensities, I'm sure that's going to look quite smooth. Maybe we'll work up to that. Right now, why don't we stick with 3, just to keep our process a little bit simple. But with these 3 switches, I'll have 8 different levels of intensity. I like it. I like this a lot. And yeah, I do like this a lot. All right, so here's what I can do. I think what I want to do is, what time are we at? Yeah, we should probably wrap this session up. What I think I'd like to do is maybe we're going to build this on the next video. We'll build this using these 3 resistors that I already have. I'm just going to have to go find some switches to use, but we have 3 resistors here. I'll find some switches that we can use, and we'll build this circuit. Actually, hang on. I do see one problem with this circuit, and it has to do with these switches. Remember, the amount of current going through these paths is quite high, and typically a switch is not really built for high current. But you know what? I have a solution. I have a solution already. Maybe if you're watching this, you might be thinking about that same solution too. All right, but we'll get to that solution on the next video. All right, next video, I'm going to build this, and we're going to see, we're going to watch our intensity change using non-PWM methods, using these switches and the 3 resistors we have. All right, until then.